So on homework 38, we're going to simplify higher roots other than just square roots. We're going to have cubed roots, fourth roots, and fifth roots. So I just put one example of each kind of ones. But the same kind of thing that we did with our square roots, we want to do with our cubed roots. I better fix my pen because otherwise I'll be writing the wrong pen. Smart pen, there we go. So when I start out and I'm going to simplify cubed roots, what I want to do is think about my list of perfect cubes. Just like with the square roots, I made that list of perfect squares. So 2 to the third power would be 8. 3 to the third power, 27. 4 to the third power, 64. 5 to the third power, 125. I don't think you'll have to go much bigger than that, but you could add to your list if you needed to. So when I'm going to simplify the cubed root of 40, I want the biggest perfect cube that divides evenly into 40. Well, if I look at that list of perfect cubes, the only one that divides into 40 is the 8, right? So I'm going to say, okay, I'm going to do the cubed root of 8 times 5. The cubed root of 8 is... Nope, that's 2, right? 2 times 2 times 2 is 8. The cubed root of 8 is 2, so the 2 comes out in front, and I'm going to get 2 cubed root of 5, then for my answer. So when I'm going to do the fourth root, same thing. I want to know what my perfect fourth powers are. 2 to the fourth power is 16. 3 to the fourth power is 81. 4 to the fourth power, 256. That's probably big enough, at least for this problem, because we're at 243. So one of those three things must divide evenly into 243, right? So what times what would give me 243, one of which is a perfect fourth power?
$81.
81. 81 times 3 is 243, right? So then I'm going to do the fourth root of 81. What is the fourth root of 81? What was that? 3, right? Fourth root of 81 was 3. This was 2 times 2 times 2 times 2, 3 times 3 times 3. So, fourth root of 81 is 3. And then I'm going to have that 3 left underneath. So I get 3 fourth root of 3. So for my cubes, I'd want to think about these numbers. That would be 2 cubed, 3 cubed, 4 cubed, 5 cubed. And if you needed to, you could add to your list. For 4s, 2 to the 4th, 3 to the 4th, 4 to the 4th, and if you needed to, you could keep your list going so that you know what factors you have to use when you're trying to divide it out. Number 3 is going to be fifth roots. So I'm going to think about our fifth roots. 2 to the 5th. What's 2 to the 5th? $32. If we do 3 to the 5th, what's 3 to the 5th? 243. And so forth. We probably won't have to go much higher than that because once we get that big, they probably don't go. The most common one they're going to do is 2 to the 5th. 2 to the 5th is 32. 32 divides into 96 how many times? 3. So I make 96, 32 times 3. The 5th root of 32 is 5th root of 32 is 2, right? Because 2 to the 5th was 32. So 2 comes out, and I've got 2 times the 5th root of 3. So they'll have you do some practice with some higher roots that maybe aren't so common that you don't know right off the top of your head. And then we go back to square root. Square root addition or subtraction. When we add and subtract, we have to add and subtract like terms. So if I have 2 square root of 3 plus 5 square root of 10, I can't add them because they're not like terms. They have to have the exact same thing under the square root. So what we're going to do is we're going to simplify our square roots first, then we're going to add or subtract them if we have like terms. So again, since we're working with square roots, we want to think about our perfect squares. 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, and that's probably big enough. So those are the list of my perfect squares. When I'm factoring them out, I want the biggest perfect square that goes into the number. So if I'm simplifying the square root of 75, which we did on the previous page, how would I factor that? What times what? 25 times 3, because 25 is the biggest perfect square that goes into 75, and 25 times 3 is 75. The square root of 25 is 5, so we get 5 square root of 3. We've got that first part simplified. The second part, we have negative 3 times the square root of 27. 27 is not a perfect square, so we want to factor it. What times what is 27? The first factor we want to be the biggest perfect square that divides into 27. 9. 9 times 3. So if you're stuck, go on your list and say, okay, 36 is too big, 25 doesn't go into 27, 16 doesn't, but 9 does. 9 times 3. Now when I simplify this, the square root of 9 is 3. I'm going to multiply it by what's already out there. So 3 times negative 3 would give me negative 9 square root of 3. Now I'm going to have like terms. It's like taking a 5x minus a 9x. Think of that square root part as your label. We're just doing the front numbers. 5 minus 9 would be negative 4, so I get negative 4 square root of 3. So number 5, we're starting out with the 2 square root of 45. The 45 is not a perfect square, so we want to factor that. The biggest perfect square that goes into 45 will be 9 times 5. So make that 9 times 5. I take out the square root of 9. The square root of 9 is 3. I multiply that by the number in front, so I get 6 square root of 5 when that's simplified. Then I'm going to do plus the square root of 20. 20 again is not a perfect square. I should factor that into 4 and 5, because 4 is the biggest perfect square that divides into 20. The square root of 4 is 2, so I get plus 2 square root of 5. So I get 6 square root of 5 plus 2 square root of 5, which would give me, I'm adding 8 square root of 5. So 8 square root of 5 would be my answer. Number 6, same kind of thing then. I have negative 4 times the square root of 18. 18 is not a perfect square. I'm going to factor that into. I want the biggest perfect square that goes into 18, so I want to use 9 times 2. 9 times 2. If I use 6 and 3, neither of those are perfect squares, so I wouldn't be able to do anything with it. So square root of 9 is 3. So 3 times my negative 4 in front gives me negative 12, square root of 2 then, right? Then we have minus the square root of 8. 8 again is not a perfect square. We're going to factor that into 4 times 2. The square root of 4 is 2, so we're going to get minus 2 square root of 2 then. So we have negative 12 square root of 2 minus 2 square root of 2, which would give me
Negative 14 square root of 2.
exactly negative 14 square root of 2. All right, so then number 7, 8, and 9, we're doing the same thing we just did, only now they made it look a whole lot more complicated because they put all those variables in there. So thinking about when we had the odd exponents, we had to factor out 1. If it was even, we left it alone because it was already a perfect square. So on this first one, I'm going to start with the 4x, and I've got to simplify the square root of 27u cubed. 27 is not a perfect square, so I factor it. 9 times 3. U cubed has an odd exponent, so I'm also going to factor that. U squared times u. Now I'm going to take out my perfect squares. So, square root of 9 is 3. The square root of u squared is just a u. Half of 2 is 1, so u to the first, right? So if I take out a 3u, I'm going to multiply it by what's in front. I'm going to get 12ux square root of 3u. Now I got to do the other side. I got a minus u in front. I'm going to simplify the square root of 75ux squared. 75 is not a perfect square. I can factor that into 25 times 3. The u, although it's not a perfect square, there's nothing I can do with it, so I'm going to leave that as a plain u. And then the x squared is a perfect square because it has an even exponent, so I leave it as x squared because I'm going to take the square root of that one. So taking out my perfect squares. Square root of 25 is 5. The square root of the x squared is an x. So putting this, I'm going to have minus 5. I'm going to write it as ux because I wrote this side as ux and we want them to be like terms. Square root of 3u. If I did everything correctly, everything behind the leading coefficient should be exactly the same. So when I'm doing adding and subtracting, they have to be like terms. They are. I'm just going to do the 12 minus the 5, which gives me 7. So 7ux square root of 3u is what my answer is going to look like when I subtract those. So if you come up and they're not like terms, you probably made a mistake somewhere and you're simplifying, go back and check your work because you should be able to add or subtract them by the time you're done, which means everything after the front number should be exactly the same. Number 8 then, we've got a w squared in front. We've got to simplify the square root of 8wy squared. What should we do with the 8? 4 times 2. Nothing we can do with the w, and we don't want to do anything with the y squared yet, since it's even. So taking out our perfect squares, what can I take out of there?
2.
A 2
And a y.
and a y. So I'm going to have 2w squared y square root of 2w. Now if you put YW squared, it's okay just as long as you're consistent. Normally we put them alphabetically so we recognize our like terms. Then we have minus 4y, and we want to simplify the square root of 32w to the 5th. 32, how should we factor 32?
6 and 7. Wait.
16 times 2. 16 is the biggest perfect square that divides into 32. So although 4 would work, it's not the best choice. 16 times 2. How about the w to the 5th? W to the 4th times w. So taking out my perfect squares, I can take out
4 and a w
squared, right? Half of 4 is 2. So if I take that out, I'm going to have negative 16 w squared y square root of 2w. So I have 2w squared y squared root of 2w minus 16w squared y squared root of 2w. My answer then would be
negative 14 w squared y square root of 2w.
exactly negative 14w squared y square root of 2w. Number 9, simplifying as much as possible. So we've got a 6u in front. We need to simplify 18x to the 5th. What should we do with that?
9 and 2.
18 is 9 times 2.
X to the 4th, times x.
X to the 4th times x is my x to the 5th. So taking out my perfect squares,
3 and x to the 2nd.
3 and x squared can come out. So I'm going to have
18x squared u.
square root of.
2x.
So 18x squared u square root of 2x. Or if you put ux squared, it's the same thing. But we'll write it x squared u. So we have plus x squared, and we need to simplify the 8xu squared. What should I do with that?
4 and 2.
4 and 2. And that's probably all the factoring we can do because we can't do anything with the x, and the u squared is already even, so we like to leave that alone. Taking out our perfect squares, we can take out
U.
2 and a u. So we would have
2 ux squared.
square root of
2x.
2x. So as long as you recognize that x squared u and ux squared are really the same thing, because we have the commutative property and we can switch them around. They are like terms, we can add them together, and so our answer would be
20ux squared square root of 2x.
20ux squared square root of 2x. Exactly. And the last 3 on this page have to do with multiplying square root expressions together. Sort of like adding, but the last part is going to be a little bit different. But we're going to start at the same. We need to simplify. I'm doing 2 square root of 32. 32 is not a perfect square, but I can simplify that. Well, how can I factor 32?
16 and 2.
16 and 2. So the square root of 16 is
4.
4. So 4 times 2 gives me 8 square root of 2 when that's simplified. I'm going to multiply it by the square root of 24, which again I can simplify. 24 I can factor into.
12 and 2.
I want a perfect square. I need a perfect square.
12 and 2.
Nope, still don't have a perfect square.
6 and 4.
6 times 4 is 24, right? So 4 and 6, because I like my perfect square first. So biggest perfect square that divides into 24 is 4. The square root of 4 is
2.
2. So I get 2 square root of 6. Now this time I'm multiplying. When I multiply, I'm going to multiply my front numbers together and I'm going to multiply my radicals together, my square roots together. So 8 times 2 is 16. The square root of 2 times the square root of 6 would be the square root of 12. Now at this point, I could be done, but I might be able to simplify it more. So I have to think about that 12. Does 12 have any factors that are perfect squares? Can I simplify that farther? It does. How can I factor 12? 4 and 3. So I make it 16 times the square root of 4 times 3. The square root of 4 is 2. 2 times 16 is 32. So I get 32 square root of 3. Now just for fun, if you have your calculator handy, somewhere my calculator is, here. If on my calculator I do 2 square root of 32 times the square root of 24, 2 square root of 32 times square root of 24. It's going to be an irrational number. I'm going to get 55.4256, so forth. 52 or 55.42. I'm going to remember that. I'm going to check my answer by doing 32 square root of 3. So if I put in 32 square root of 3, do I still get the 55.42, so forth and so on? Sure enough, I do. So that gives me a good idea. Yep, I did it right if I want to try to check my answer that way. So, number 11, I want to simplify the square root of 45 times 3 square root of 48. Again, 45 is not a perfect square. How can I factor 45? 9 times 5. Square root of 9 is 3. So I get 3 square root of 5. Then I have times 3 square root of 48. Whoops, 48 is not a perfect square. I need to factor 48. 48. Biggest perfect square that goes into 48. The biggest perfect square that goes into 48. Nope. There's a bigger perfect square than 4. What one?
24 times 2.
Neither of those are perfect squares. Ah, 16 is the biggest perfect square. So 16 times 3 is the pair you'd want to use. So a lot of times if 4 works, check to see if 16 might also work. Because you want to use the bigger one, because that makes your life a lot easier. So square root of 16 is 4. 3 times 4 would give me 12 square root of 3 then, right? So now I'm going to multiply. The 3 times the 12 is 36. The square root of 5 times the square root of 3, 15. Now if I think about all my factors of 15, I've got 1 and 15 and 3 and 5. Well, I don't have any perfect squares that I can simplify because 1's not going to do me any good. So on this one, I can't go any farther. That's just going to be my answer. I'm stuck at 36 square root of 15. I can't go any farther than that. So sometimes you'll just be done after you multiply. One last one on this page because these are probably a little trickier and you probably haven't done much with these. So number 12, we've got 3 square root of 32. 32, we factored that a few times. What was the best way to factor that one? 16 and 2. Square root of 16 is 4, so I'm going to get 12 square root of 2. 18. How did we factor 18? 9 times 2, so when I simplify that, I get 3 square root of 2. Now notice on this one, both things under my square roots are the same. We'll see what happens when we multiply those. 12 times 3 is 36. The square root of 2 times the square root of 2 is going to give me the square root of 4. 4 happens to be a perfect square, right? The square root of 4 is 2. And 36 times 2 would give me 72. Nothing left under the square root because 4 was a perfect square. So if you happen to have your calculator handy and you did that one on your calculator, 3 square root of 32 times square root of 18. Sure enough, I just get a plain old 72 on my calculator. I don't get one of those big, long, crazy decimals because it turned out to a nice integer. All right, so that will be the next 4 things in that purple section of your pie chart.